Hey everyone, this is Miss Englert. These are your notes for today, Friday, April 23rd, 2021. How do planetary winds and small scale air currents circulate? So, I know that the GIFs aren't moving on this page, but I will be uploading the actual PowerPoint with this so that you guys can actually see these shapes. You will also need to so you're going to write about how you're feeling, so you can just use the text here, but you'll also need to, on the next slide, use this image actually moves. So if you look on the PowerPoint that I'm attaching to this, you'll be able to see how it's moving. It actually shifts up and down. So you'll see the red band moves up and the red band moves down, as well as the blue bands expand and contract as well. You're going to say, what do you think causes the displayed shift in the circulatory system? Right, so this image here is on, I need to figure out what page on the Earth Science Reference Table it's on. I thought it was 13. It could be, I think it's page 13. I'll check. But so this image actually shows you the different parts of the troposphere. So here it actually shows global currents. So it has our wet bands and it has our dry bands. So I want to remind you guys, actually I'm going to use a highlighter on this. So if air is cold, air does not like to hold water if it's cold. If air is warm, it will hold lots of moisture and it will also rise. So these bands where you see wet there, and then there's a line here that says wet and a line here that says wet, and you guys will highlight those. Those are all warm. So if you notice, if you trace off to the side, the arrows actually rise from these wet bands. So here it's also rising, here it's rising, here it is rising, and here it is rising. So as it follows around, let me make this a little smaller, it actually eventually cools down and then it drops. And those bands where that air is dropping, that air is more dense and it's dry and cold because it's been up in the tropopause getting cooler as it is rising in altitude. So we get these circulation systems where that cool air or that cold air moves across the Earth's surface. So here again, that air is actually going towards the Earth's surface, towards the Earth's surface, towards the Earth's surface, and we get these little convection cells all up in our troposphere. So there's a lot of stuff going on. So the name for these are convection cells. So if you just obliterate everything else that was in there, and then you guys can draw on this, if the arrows are going down, so for instance these guys are going towards the Earth's surface, if those arrows are going down, those arrows are showing cool, dry air. And on those lines that are going down, we are going to get bands of cold or cool, dry air at the Earth's surface. If those arrows are rising, such as here and here, I think the rising arrows are a little bit easier to see. Oops, sorry, my cat just walked across my screen. A little behind the scenes for you. So these arrows are rising there. So these lines are actually going to be warm and wet air that are rising. And we have some more over here. Oh, that was the worst arrow. We have some over here, up and up and up, and these areas again are going to be cool, or sorry, they're going to be warm and wet or moist, and then these guys are dry because as you see on the poles, we have air coming towards the Earth's surface again. I personally like this diagram. I usually make you all color your Earth Science Reference Table in person and get these beautiful blue and red lines. So a convection cell is the circular pattern of air as it rises and falls due to differences in density. And so what causes those differences in density? Remember that it has to do with cold sinks. Oh man. So if whatever substance becomes cool or cold, it's going to contract and it will have the same amount of mass in a smaller volume, which means it has big mass over low volume, which means dense. So if it is warm, those objects tend to expand in volume. They don't change their mass, so then the mass is staying the same over a low volume, which means that they're going to be less dense and they're going to rise. So again, going back to what I just said in a little more detail, hot air is less dense, so it rises, and then cool air is more dense, so it sinks. You guys will write those words in for us. So these planetary wind belts are what you guys just drew, or at least a few slides ago should have drawn. Hopefully you did. These planetary wind belts are zones on the Earth's surface where the wind blows, generally speaking, in the same direction most of the time. Why are they curved, you might ask? They are actually curved due to something called the Coriolis effect. Coriolis effect. Alright, so it is a very complicated thing that is quite tricky to explain, and in this space I'm not going to explain it. I will give you guys an Edpuzzle which will thoroughly explain it for you all. Instead, we are going to let you just know Coriolis effect. If you ever see Coriolis effect, that is typically the answer that you're going to choose on the Regents. So if you ever see that word, that's the word that you're going to choose. Alright, so these prevailing winds, we have different names of winds here. And they're the winds that blow from the same compass direction most of the time. So polar easterlies blow from the east. The westerlies, in the northern hemisphere, they actually blow from the southwest. The trade winds in the northern hemisphere blow from the northeast. So those, if you've ever heard of like the prevailing westerlies, I think that's if you've heard of them, you've probably heard of them in like Pirates of the Caribbean is most likely the places where you've heard the prevailing easterlies or westerlies. Like Dead Man's Chest, think about that. So what I'd like you to do now is you're going to go ahead and color the areas of surface convergence red, and then surface divergence blue. So convergence means coming together, and divergence means blue. So if you see two lines going towards each other, so I'm going to go ahead and highlight those two lines. So this line is going towards, and this line is going towards. That means they are converging. They are coming together. If they are diverging, they are moving away from each other. And it has the same pattern. I always like to hear this in the class. I'm like, hey, it's a pattern. You don't have to know what it does. You just have to find these and color it. Heck yeah. It's a pattern. I would not get mad at you for finding a pattern. It's very, that is how you do it. Like that is how you science. You find patterns and you try to explain them. And then I just so happen to also give you guys a key. You're welcome. Right, so review. This is from last week, I think. So, the wind blows due to differences in air pressure. So remember, high pressure is going down towards Earth and it wants to leave that area. So imagine if you are under a lot of pressure, right? So you're under a lot of pressure. Somebody keeps asking you to do things. You want to get out of that area, so you're going to leave. If there's not a lot of pressure, you're just like, you're happy to chill. Like, you'd rather go somewhere where someone's not yelling at you rather than going somewhere where a lot of people are yelling at you. Okay, alrighty, next slide. So we have these pressure belts. We've already shown this a little bit. So you guys are going to label these. Where we have cool, dry air, those are going to be high pressure belts, because remember the air is falling towards the Earth's surface, whereas our low pressure belts, that air is rising. So I just want you guys to use the text tool and add those in there. This is just an example of what it looks like. Typically in those dry places there's a lot of sunshine. And then on the low pressure areas it tends to be cloudy and you get a lot of precipitation. Otherwise known, well, depending on whichever latitude you're at, you will get a lot of either snow or rain, depending on where you are. Okay, let me check out this next slide. So you're going to go ahead and read this paragraph and say, what does it mean? Write it in your own words. Right. On this diagram, remember that this is a flashback to our last unit, talking about how the sun's rays shift or appear to shift on Earth's surface because of when we are tilted towards or away from the sun in the different hemispheres. So during the June solstice, the northern hemisphere is tilted closer to the sun, rather it's tilted more directly at the sun. Then during December in the northern hemisphere, we are tilted farther away from the sun. So different parts of the Earth, if you look at this diagram, different parts of the Earth get more hours of sunlight during different times of the year. So let's say that we are, actually I don't even have to just say that we are here. So we are right about here on Earth's surface and still right about here. So during different times of the year, so during the summertime we get about 15 hours of sunlight, whereas during the winter time we get more like 9 hours of sunlight a day. So that means that there's a difference of about 6 hours of daylight that we receive during the summertime versus during the wintertime. That's 6 more hours. Imagine if you are sitting out in the sun for 6 more hours a day than you usually do. You're going to be so tired. The sun is so draining. So that longer hours of daylight means that surfaces are going to heat up more, and the air is going to behave differently because the air will be heated more during the summer and not heated as much during the winter times. So the reason why these pressure belts shift up and down, again, you can go to the slides I attached if you want to see it moving up and down. This is the reason why these sort of belts tend to change. So we'll receive different extreme weather changes in some regions. So this is the reason for things like hurricane season or in tornado season, is because of these shifting winds up and down. We'll learn more about extreme weather as we go through the semester. Our last few slides here about local winds. So these are small scale circulation. So if you look on this diagram, during the daytime, the sun is heating up the ground and it is heating up the ocean. So the ground is going to heat up fast. I guess we're doing this in purple. So the ground is going to heat up fast, and water does not really change temperature, so it doesn't heat up fast, so it's going to heat up very slowly. So then what happens, remember, if it's warm, our air is going to rise. If it's cool, that's going to be high pressure, right? So that's our high pressure, and this is low pressure. We want to get away from high pressure. We as humans want to, and air is going to move from a high gradient to a low gradient. So then during the nighttime, when everything is cooling off, the ground is going to cool down fast too. But the water is still warm from the daylight and is slowly going to release that heat. So then we are actually going to switch directions on our cell. So we have lower pressure at night above the water, and then we have high pressure above land during the nighttime. Oops, here it is again. So they have different names for those. A sea breeze is a wind that blows from the ocean onto the land. So remember that breezes are named after where they come from. So if it is an easterly wind, it comes from the east. If it is a sea breeze, it comes from the sea. So sea breeze are going to be winds that blow from the ocean onto the land during the day. A land breeze is a breeze, aka wind, that blows from land to sea. So a land breeze originates on land. That's why, like, in the morning, if you've ever seen like America's Next Top Model, at in the middle of the day, I don't know why I asked you all. So in the middle of the day, you will actually, they don't really take pictures on the ocean much during the middle of the day because their hair is all gonna blow, like, if they're standing there and they're facing away from the ocean, that their hair is just gonna blow up like crazy. Whereas if they're here and if they're like standing at sunset, this is a terrible drawing, then it's actually gonna blow their hair back in the breeze and look so elegant. Oh man. Alright, so last thing to recall, I actually don't know that you guys have recalled this, so this is just a note to E, not to you guys, teach this. I don't think we ever actually taught you guys this, so whoops. Alright, so we will teach you that. Oh, eventually. Oh, dang, I thought that was the last one. Oh, why do we have so many? Alright, so I guess this is going to be your exit ticket here. Use the following vocab to write your answer. These are your... Nope, we didn't talk about specific heat, so we don't have to do this one. You're welcome. So I will teach you guys about specific heat on our maybe next lesson, but definitely next week for sure. Alright, so I hope you all have a good weekend, and don't forget to submit these. Thank you so much for watching. Bye all.